section 2.3, which is deductive reasoning, and it's not up yet. Alright, cool. Alright, so deductive reasoning. Can somebody look at that word deductive and tell me what it sounds like? Is there another word that we know that it maybe sounds like? What do you think? Inductive. Okay, sounds like inductive. So can somebody remind me what inductive reasoning was? Yeah, sure. Yeah, based on a pattern. So we look at a pattern, we get a general rule from that. So we talk about gravity, right? If I take the pen and I drop it, we really quickly start to generalize a pattern. Deductive reasoning is a little bit different. Deductive sounds like detective to me. All right? And so a detective, what do they gather? What do they look for? Look for clues and evidence, and they have to build their case. And they can only do what they have in terms of evidence. So if they know in their gut that somebody's guilty, they still need to be able to prove it. All right? So there's all sorts of cases. The most famous one that I can think of is the O.J. Simpson case, where popular culture thought that he was guilty, but he was found innocent because there was no proof. There wasn't enough proof, enough evidence to link him to the crime. Okay? So when we're doing deductive reasoning, we have to be really, really careful about what we know for sure. It has to be proven. It has to be for sure. So we have two laws. The first one is called the law of detachment. Here it is. If a conditional is true and its hypothesis is true, then the conclusion is true.
It's an if-then statement.
It is like an if-then statement. Very nice. So it is a condition. What this says is if I have a true conditional statement and I'm given the hypothesis, then I'm also given the conclusion. All right, so an example, we'll do a couple. If it's sixth period, then you're in geometry class. And then I tell you, all right, it's sixth period, what can you conclude? Now I started with a true statement. If I start with something that's false, if it's sixth period, then the building is on fire. And I say it's sixth period, what does that mean? It doesn't, right? Because my premise, my starting point wasn't true. I can't make up my own conditional. The conditional has to be true. If it's sixth period, then we can all fly to the moon. Well, now it's sixth period. Does that mean we can all fly to the moon? Yeah. No. We'd hope, right? But I've started with something that's false. I can't start with a false and prove something that's true. So be careful. We have to have a true statement to start. All right, so here's our law of detachment. And we can build something called a truth table, which things can be true or false. And if we look through it, we start with the conditional. So if we were to look at it symbolically, what does the law of detachment tell me that I have to have for the conditional? Can it be true or false? It has to be true. All right, I have statement P and I have statement Q. So here is a conditional. We talked about this one before. If you're alive, then your heart is beating. All right. It's a conditional because I have if then. Is it a true conditional?
Yes.
Yes. So in my truth table, I'm given the conditional is true. If I'm given a fact, apparently like Joe today, Joe is alive. So I'm given a piece of information. I'm given the hypothesis. What can I conclude? Yes. So I'm given that P is true. According to this law, I can conclude the conclusion is true. So his heart is beating. All right. So conclusion, Joe's heart is beating, which means that that's true. Easy so far? Good. Let's see if I can confuse it. So that's a law of detachment. If you're given the hypothesis, then you know the conclusion is true. If you started with the true statement. All right. Let's look at the second law, which is the law of syllogism. That word is a mouthful. What this says, if P equals Q and Q equals R are true, then P equals, if P given R is true. So if I have a statement, if P then Q, and then if Q then R, then I know if P then R. And I have a nice big truth table. Let's see if I built this correctly. So let's try to think of an example, a real world problem here. So if I said, if it's Monday, then you have sixth period. If you have sixth period, then you're in geometry class. So what can you conclude with those pieces of information? What do you think?
Geometry classes on Monday?
If it's Monday, then I have geometry class. Right? I get linked by that sixth period. So if it's Monday, then I have sixth period. If I have sixth period, then I have geometry class. So we can make another conditional. Right? This is another conditional. If it's Monday, then I have geometry class. All right? So we have to be given two true statements to start with. If it's Monday, then I have sixth period. That's true. And if I have sixth period, then I have geometry class. That's true. If all of those are true statements, if I'm given P, it's Monday, we can conclude you have geometry class. All right. So all of those are true. Now, let's think of our example. If I give you the conclusion, it's geometry class. Can you conclude that it's Monday?
Yeah. Oh,
No.
No.
Today would be a counterexample, right? So we got to be careful. Which piece I have to be given? I have to be given the hypothesis. I have to go across in order. If I'm given a conclusion to start with, it might not be true. Yes, Alex?
If the R statement wasn't true, would QR and PR also be false? So if R is false,
This would be false. So these, right. So if R is false, if I said if it's Monday, then you have sixth period. If you have sixth period, then you're in calculus, right? I'm not going to conclude if it's Monday, then you have calculus. That would be a false statement. So that, well, that would still work. If it's Monday, then you have sixth period. That's still true. But this link is false, which means the final link is false. Yeah. So if we wanted to build more truth table values, if we made this false, we would also have this is false, this is false. That's a good question. All right. Let's look at an example. You don't have to copy this down if you want, but let's just try to understand it. You're going to do a bunch of examples in a second. So, if a person is 8 feet tall, then they are giants. Okay? If you are a giant, then your shoes are at least the size 22. Okay? So how many statements do I have up there?
3.
3, right? I have 8 feet tall, giant, and shoe size. So if I use this law of syllogism, what can I conclude? And if I'm given that Andre is 8 foot 3 inches tall. Alright, so I now have a piece of information. You're going to see something like this on a quiz or a test in the book. I need to make a conclusion using the law of syllogism. So I need to first off think about what I have. So here's statement P, here's statement Q. This piece right there, being a giant, is again statement Q. And the last one, shoe size, is statement R. So if P then Q, if Q then R, what does the law of syllogism tell you can do? And P then R. So what would that be in words?
If a person is 8 feet tall, their shoes are at least size 22.
Good. So we can conclude if a person is 8 feet tall, then their shoes are at least size 22. So what can we conclude about Andre? Well, we're given he's 8 feet tall. He is a giant, and what else? The shoes are at least 22. Right?
So you want like 2 things?
Yes. Because we can conclude with the law of syllogism, if a person is 8 feet tall, then their shoes are 22. We could take this and directly conclude the shoe size. We can also go, he's 8 feet tall, he's going to be a giant. If he's a giant, his shoes are that. Yeah? There he is. Alright, so I have a couple of examples that I want you to work on. I want you to open up your workbook, please, to page 279. It's okay. Yes, you can go get it. Alright, so let's talk through the first 9 here. I want to make sure that we're all on the same page. I know that some of this seems like an obvious solution, but that's good. It will get complicated, and just trying to understand the reasoning that people are doing is a really good thing. And you often find in sports announcers that they don't follow this deductive pattern as exactly as they should. And I'll talk about that in a second. So, number 2, if the football team wins on Friday night, then practice is canceled for Monday. Well, now I know the football team won by 7 points on Friday night. So who can tell me what they can conclude from that information? Football practice is canceled. All right. So there's no practice. Nod your head if you agree. Yes. All right. If a triangle has one 90-degree angle, then the triangle is the right triangle. Well, I'm given a triangle with a 90-degree angle. What can we conclude? It's a right triangle. All right. Easy enough. The next one, I need to use the law of syllogism. So it says, if you liked the movie, then you saw a good movie. If you saw a good movie, then you enjoyed yourself. Well, I can drop out that middle piece, and I can link it with, you saw a good movie, to get, if you liked the movie, then you enjoyed yourself. The next one becomes, if 2 lines are not parallel, then they intersect at one point. And then the last one, number 6, if you vacation at the beach, then you must like the ocean. If you like the ocean, then you like Florida. I can conclude, if you vacation at the beach, then you will like Florida. Alright, thumbs up if you're with me so far. Good. Next one, number 7. If Robbie wants to save money for to buy a car, then he must get a part-time job. Robbie has started a new job yesterday at the grocery store. Who can tell me what they can conclude from that? Emily.
Robbie wants to save money to buy a car.
Not quite. No. Yeah, it's not possible.
Told you.
So this is a key one.
That's what I thought.
If I think about this, so it says, if Robbie wants to save money to buy a car, then he must get a part-time job. So what's the hypothesis in that statement? Alex. If he wants to save money. So we're given that he started a job. We're given the conclusion. We're not given the hypothesis. We don't know, maybe Robbie doesn't want to save money. So it's not possible. We don't know for sure. And this is where we have to be detectives, right? We have to go with what the evidence shows us. The evidence doesn't show us that we have our hypothesis. All right. The next one, if a person lives in Omaha, then he or she lives in Nebraska. Well, Tamika lives in Omaha, so what can we conclude, everybody?
She lives.
She's in Nebraska. That's fine. All right. And the last one, if two figures are congruent, then their areas are equal. And the area of ABCD is equal to the area of PQRS. So what can we conclude? We can't conclude they're congruent. So if two figures are congruent, that's the hypothesis. Then their areas are equal. I'm given equal areas. I'm given the conclusion. Does that mean the hypothesis is true? No, think about it. If I had a 2x4 rectangle and a 1x8 rectangle, those are the same areas. They're not congruent. Shelby.
So what would the hypothesis for that be?
So the hypothesis for number 9, if they are congruent, then the areas are equal. The converse is, if the areas are equal, then they're congruent. But the converse is not true. So you can't be given areas are equal and assume figures are congruent. Alright? And this is my sportscaster pet peeve. You'll hear, if you watch any football or basketball or whatever, they'll talk about this team is 23-0 on a Monday following a Tuesday where they played in a dome. Right? So we have this idea of if something, then something else. They flip it around and say, well, then if they're playing in the dome, then they're going to win. Right? So you got to be really careful about flipping if-then statements around. They're not always true. The converse is not always true. All right. I want you guys to look at 10, 11, 12 for a couple minutes, and we'll talk about those, and we'll get on our way. All right, so let's talk about 10, 11, 12. I'm given, if it's raining, the temperature is greater than 32 degrees Fahrenheit. If the temperature is greater than 32 degrees Fahrenheit, it is not freezing outside. Then I'm given that it is raining. All right, so what can I conclude from that, Alex? It is not freezing outside. Okay? So I'm given it's raining. That tells me the temperature is greater than 32 degrees Fahrenheit, which tells me that it's not freezing outside. All right. If I'm given that it's not freezing outside, do I know that it's raining?
No.
You don't. Okay? It has to go if-then. It's not biconditional. It doesn't go both ways. So you've got to be very careful. All right. So our conclusion, it's not freezing. Next one, if you live in Providence, then you live in Rhode Island. If you live in Rhode Island, then you live in the smallest state in the United States. And we're given that Shannon lives in Providence. Hey, hand up. What can we conclude? Good. Nice and loud.
Shannon lives in the smallest state.
Good. So our conclusion is she lives in the smallest state in the United States. Okay? If we said that Johnny lives in the smallest state in the United States, can we conclude that he lives in Providence?
No.
No. Are there other cities in Rhode Island?
Yes.
Yes. He could live in one of those. All right. Last one. If it does not rain, the track team will have practice. If the track team has practice, the team members will warm up by jogging 2 miles. It does not rain on Thursday. What do we know? Ellie?
Thursday, the track team will warm up.
Good.
And have practice.
So we can conclude on Thursday the team will warm up by running 2 miles. All right. So really the only way you can get yourself in trouble on these is